Hey guys, I want to give you another day to work on simulations because they are pretty important and can be a little bit tricky. So nothing really new to lecture over for randomness. We're just going to go right into the example problems here. So let's suppose that you are a young couple and you want to have two children of each sex. So two boys and two girls. On average, what would we expect for the number of children that you'd have to have until you had two of each sex? So this is number 32, dyslexia, right? A bigger family. Suppose a couple will continue having children until they have at least two children of each sex, so two boys and two girls. How many children might they expect to have? So we might be able to answer that question with probability, but let's run a simulation using random integers to try to figure out what we might expect. So we're going to run, I believe, 20 trials on this one using random integers from our calculator. So to do that, we're going to assign 0 and 1. So just like before, we'll do 0 will represent a girl, 1 will represent a boy. Of course, in this, it doesn't actually matter which one. We just need to make sure we have two zeros and two ones, but we will define these before we actually start. We're going to use the calculator instead of random integer table because random integers, we can use even and odd numbers to represent boy or girl. You could do 0 through 4 to be a girl, 5 through 9 to be a boy, but it's actually easier just to read zeros and ones. So we're going to use the use our graphing calculator. So if we go to math, arrow to the right to the probability, and then down to random integers, we're going to go a lower of 0 and upper of 1, and we're going to do 8. So you could have to have more than 8 children in order to have that have two of each sex, but that would mean that you'd have to have like 7 girls or 7 boys and only 1 girl or only 1 boy, but that seems pretty rare, right? So we'll just do it up to 8, and if 8 doesn't go long enough, we'll do another one and we'll start from the beginning and just keep counting from there. So not a big deal. So we'll paste that, and so let's describe our response variable. So the response variables we're actually graphing, that's going to be the length of the trial, which is how many components does it take before we finally satisfy 2 boys and 2 girls, right? So the number of children in each trial until you have 2 of each sex. So use your calculator to simulate 20 trials. You don't have to write the results. We're just going to write the response variable down, okay? So the first one, all right, so it looks like, oh, wow. So sure enough, there's 8 altogether. So we had 7 girls and only 1 boy. So we need to keep going past 8. That most couples would probably stop at 8 children, but maybe not. I come from a large family, by the way. My parents had 7 children, so anyway, so it looks like on the 9th one, we finally got another boy. So our first one for the response variable, of course, just go off whatever you get. We might actually have the same stuff because of, the seeding issues and with the graphing calculator. So I'm going to say the first one, the response variable was 9, and then we're going to do another one. So hit enter again. We'll just start over. Okay, so we had our second. Wow, so this would be within 4. So 2 would be 4. Okay. And I'm just going to do a few of these till you get the idea. All right, so it looks like that was 4 again before we had both. And then, ooh, looks like we're looking for another girl. So it's more than 8, which is unusual, but it can happen. And then that would be the 9th one. This would be the 10th one. So it was 10 children before you finally had 2 of each. At that point, you might just adopt. Okay. But you never know, right? You don't know what's going to happen. All right, so this looks like 4 and then 5. So by the 5th one, we did. So the 5th trial, we'll have a response variable of 5. I finished out all 4 of my trials. These are my results. You can use your own. It really doesn't take that long to do. And I'm going to add them all together. When I do add them all together, that's going to give me 108 children. That's a lot of babies. But again, that was 20 trials. So we're going to divide that by 20 to get the average amount, which when I do, I get about 5.4 children. So our conclusion is on average, our simulation suggests on average we would expect 5.4, a couple to have 5.4 children before having 2 of each sex. So it's a bit wordy, but our simulation suggests couples should expect to have on average 5.4 children before having 2 of each sex. All right, number 28, blood donors. A person with type O positive blood can receive blood from any other type O donors. About 44% of the U.S. population has type O blood. At a blood drive, how many potential donors do you expect to examine in order to get 3 units of type O blood? Describe how you'll simulate a component. So if we have a probability of 44%, because it doesn't end in zero, like 40% or 50%, we have to use more than one digit, right? We can't just use the digits 0 through 9 to represent one of them. So we have to use two digits in this case. And so we're going to let 0 through 43 represent a type O positive blood donor, and 44 through 99 to be everything else. So 44%, because if we're going from 0 to 43, that would be 44%. And then 44 to 99 would be everything else, every other blood type, which is 56%. Describe how you simulate a trial. So a trial is basically however many components it takes until we reach what we're looking for, which in this case is 3 units of type O blood, or 3 type O patients. So we're going to simulate the trial by running the components. We'll continue the components until we find 3 O positive donors. Describe the response variable. So the response variable is the length of the trials, which in this case is going to be the number of patients we examined before finding 3 O positive donors. All right, so we want to use the random numbers listed below to run 10 trials. So what we want to do is pair these off in groups of 2, and we're looking for 3 of them that are in numbers from 0 to 43. So first we're just pair off, we have 76, then we have 48, 88, 88 again, 99, and 15. So 15 is going to be the first one that actually works. We can circle the ones that work, you can put a check mark under them, it doesn't really matter. Just as long as we separate them from the others. We have 86, 0, so check that one. And then 73, 70, and then 13. So 13 is going to be the third one. I've got them color coded so it's easier to see. That really helps. So we want to count how many do we have before we got to the third O positive donor. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this was the 11th one. So I'm going to write that down here. That's like our response variable, right? That's the length of the trials before the number of components before we were able to stop. All right, let's keep going. So we got 43, 18, and 40. Well, that was pretty simple. That was just 3, so that was easy. 41, 69, 20, and 21. So that length here, again, you can check them off, whatever. I'm just being lazy at this point. That would be, let's see, 1, 2, 3, 4. Okay, and I'm just going to pause the video and finish this up here, but you could do it on your own. After a while, I mean, this isn't the most exciting thing that you do, but it's pretty simple. Make sure that you know how to do it. Make sure that you're marking it, and you can show me how you ran your simulation. So I'm going to finish this up real quick, and then I'll see you in just. All right, so now that I have all of my response variables, I want to add them all up together and divide it by the number of trials that we ran. So I add them all up, I get, I believe, should be 57, right? Then we divide it by 10 because that's how many we have. We're going to find the average, in other words, which is 5.7. So our conclusion we would have would be our simulation suggests we should expect to have to examine on average, or an average of 5.7 donors before we have 3 O positive blood donors. All right, so not too bad. If you have any questions, of course, you can ask on Google Classroom or through Remind. Just there's pretty simple and easy day today, just giving you some more practice with simulations. I believe the other questions, the answers are in the back of the book. So if you need any help, please let me know. If not, you guys have a good weekend, or if you're doing this on Tuesday, then I hope you guys have a good Wednesday off.